In this video, let's take a look at an application word problem dealing with the law of cosines together. In this problem, we're going to have two trains that are leaving from the same point. They're going to go ahead and travel along in straight lines, and they're going to be going in different directions by an angle of 72 degrees. While one of these trains is traveling at a rate of 64 miles per hour, the other train is going to be traveling at a rate of 52 miles per hour. What we're going to do is we're going to go ahead and calculate and approximate to the nearest tenth of a mile how far apart these two trains are going to be from each other after 30 minutes has gone by. Let's start by drawing a picture so we understand what's going on here. Alright, so I'm going to start by just drawing a dot here, just like this. And this dot right here represents our starting point. Now one of our trains is traveling at 52 miles per hour, so I'm just going to go ahead and draw a line going to the right to show that train. And our second train is traveling a little faster at 64 miles per hour, so I'm going to make it a little longer, and I'm going to go up to where I think about 72 degrees is, maybe something like that. We were told that angle measure between these two trains are differing by 72 degrees, so the angle between these two trains is going to be 72 degrees. And after 30 minutes, each of the trains are going to stop over here and over here. Now the question is asking us how far apart these two trains are going to be from each other after 30 minutes, and that's going to be the distance between these two dots. Now just to make this a little bit easier to understand, this over here as train number 1, this line as the path of train number 2, and this line segment will represent the distance between the two trains after 30 minutes. Now let's take a look at train 1 in a little bit more detail. We were told in the problem that this train was moving at a rate of 64 miles per hour, so that's going to be 64 mph, or 64 miles traveled in 1 hour, which is the same thing as 60 minutes. Now you may be tempted to use this number of 64, but remember, these trains aren't traveling for a full hour, they're only traveling for 30 minutes. That being said, we're going to go ahead and divide that 64 by 2 to find out how far it travels in half an hour or 30 minutes. Cutting that in half, we find out that this train, or train number 1, is actually only traveling 32 miles. So I'm going to go ahead and write that on this side of the triangle. Now let's take a look at train number 2, which we were told was traveling at 52 miles per hour. And so we're going to go ahead and write down that speed of 52 mph, and that's how far this train is traveling in 60 minutes, or 1 hour. Similar to train number 1, we're going to go ahead and cut this number in half because we're only traveling for half an hour. And we're going to end up getting that this train is going to travel 26 total miles in those 30 minutes. So let's go ahead and write down that 26 down on that side of the triangle. Alright, so here we have our picture of what's going on in this particular scenario, and we have a side angle side situation here, so we're going to use the law of cosines. Let's go ahead and remind ourselves what are the law of cosines. If you don't have it memorized, here they are. So here we have 3 different versions of the law of cosines depending on what we are looking for. Notice how we have 3 different versions of the law of cosines, and we can use each one depending on what we are trying to do or what information we're given. Now in this particular case, we are given this angle measure of 72 degrees, and we're looking for this opposite side of it, or the distance between those two trains. And so we can see here that we're going to be dealing with angle A as well as side A, which is over here. That being said, we're going to go ahead and use this first version because that's going to help us find the distance between those two trains. Just to be clear, angle A in this problem is going to be 72 degrees, side C is going to be 32 miles, side B is going to be 26 miles, and we're going to be looking for side A, which is going to be representing the distance between these two trains after 30 minutes. Alright, so let's get a little bit more space here and write out this formula. Alrighty, so there is our original formula for the law of cosines that we're going to use for this problem. And so let's go ahead and make some substitutions based on what we knew from our picture. Substituting in, we don't know the distance between the trains, so we're going to solve for that. In terms of B here, that's a distance that the train 2 has traveled in 30 minutes. This little c represents how far train 1 has traveled. Same thing for this B and C, that's going to be 26 and 32 again. And then we're going to take cosine of angle A, which we know is going to be 72 degrees. Let's go ahead and now square this 26 and square this 32 and just follow the order of operations. Squaring that 26, we get 676, and squaring that 32, we get 1024. On top of that, we can go ahead and multiply this 2 by 26 and 32, and we're going to get 1664. Next, let's just go ahead and add these two numbers together and combine those two constants. And by combining that 676 and 1024, we're going to get 1696. Then let's just go ahead and isolate this variable of A that we're looking for, or the distance between the two trains after 30 minutes. We can do that by going ahead and taking the square root of both sides. By going ahead and taking the square root of the left side, we're just going to get A by itself. Then we go ahead and take the square root of the right side, it's going to look something like this. What we can do finally here is just plug this entire right expression into a calculator. and rounded to the nearest tenth, we should get about 34.4. This right here would be the approximation value for side A, or the distance between these two trains. So let's take this 34.4, go back to our picture over here, and we can go ahead and write that as our distance between these two trains after 30 minutes of 34.4. Now it's not perfect, but it's a pretty close approximation. So we can go ahead and take a look at this picture and summarize this all together at the bottom here. Both trains are going to start at this bottom left location here. Train number 1 is going to travel 32 miles in that 30 minutes. Train number 2 is going to be moving in this direction and travel a total of 26 miles in 30 minutes, and they're going to end up in these two locations, train number 2 and train number 1. And if we take a look at the distance between them, we can use our law of cosines to calculate that, and that's going to be the length of this line segment right over here. Therefore, we can go ahead and conclude that in 30 minutes, these two trains are going to be about 34.4 miles away from each other. So there you have an application word problem where we can go ahead and use the law of cosines to help us solve this type of problem. If you found the video helpful, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.